Hello my dear students, welcome to IMS GET Academy. My dear students, the fundamental series is the one important series where we want to brush up the basic concepts. If I talk about geotechnical engineering, I am covering all the basic concepts. We have started with properties of soil. We want to understand which properties are required to determine the bearing capacity or the shear strength, or how do you classify the soil. Some of the properties like permeability, which plays a very vital role in the case of seepage and all. So in this today's session, I would like to cover the effective stress. Okay, my dear students, in this today's session, I would like to cover the effective stress concepts. Like, why do you want to study about the effective stress? What is the reason to study effective stress? So all these things will be covered in this session, my dear students. Before starting the topic, let us discuss what we do at IMS GET Academy. We at IMS GET Academy offers 800 plus hours of GATE coaching. We provide self-recorded sessions, online sessions, and we provide the offline GATE coaching at Jayanagar and also Malleshwaram at Bangalore. We also provide the offline GATE coaching at Vijayawada. In addition to this, for every success, you should have a strong content. So we provide subject-wise material, exercise book. Very good afternoon, Gagan. We provide exercise book where it covers level 1, level 2, level 3 questions. And in this level 1, level 2, level 3 questions, we cover the NIT, MCQ, multiple select question. And remember, my dear students, if you see in the GATE, previous year questions plays a very vital role. Hence, we are providing the GATE question booklet with 34 years of detailed solutions, which contains the key pointers, alternative solutions, and the QR code for the difficult level questions. Apart from this, if you want to test yourself at every juncture, we are providing 130 plus tests. We are offering the chapter test, subject test, advanced level test, multiple subject test, and also we are offering you the All India mock test, which will be replica of the GATE pattern. In addition to this, the key success for student success is the IMS one-to-one mentorship. We are providing 12 plus mentorship sessions to the one-to-one to the student. And this entire year, we understand what should be the roadmap. We understand what is the weakness of the student, what is the strength of the student, how the weakness can be converted into strength. Similarly, we are providing the doubt solving portal where we have the doubts will be resolved within 24 hours of time. Now, my dear students, you can visit our, here is the numbers listed below. And we have Rahman, the education advisor sitting at Jayanagar. You can contact him for any official data regarding the admission process at Jayanagar, online, offline, or self-recorded sessions. So let us quickly start our session. What we want to discuss. Very good evening, Mathan. So my dear students, today I would like to discuss the topic called effective stress. Today I would like to discuss the topic effective stress. And what do you mean by stress, my dear students? What do you mean by stress? Before starting this, I would like to discuss what do you mean by stress. Okay, today we are going to discuss one second students. Today we are going to discuss a topic called effective stress. Okay, now what do you mean by effective stress? Effective stress is nothing but the intergranular pressure between the soil particles. What do you mean by effective stress? It is the intergranular pressure between the soil particles. Now, why the stress is known as effective stress? Let me tell you. Because it has an influence on the engineering properties like void ratio, shear strength and all. So, let us discuss that, students. Okay. Now, let me tell you, what do you mean by effective stress, sir? Effective stress is the intergranular pressure between the soil particles. It has a measurable influence on the engineering properties of the soil. If we talk about the total stress is due to the self-weight of the soil or due to the overburden pressure, or you can say earth fill. So what do you mean by pore water pressure again? 1 second, students. Okay, students, just give me a second. Okay, meanwhile you can just go through the intro. I'll be back in 2 minutes, sir. Matan? I can print. Hello my dear students, sorry for the inconvenience. There was a technical glitch for 2 minutes. So let us move on to the topic. So today I'm here to discuss about a topic called affective stress. Today I'm here to discuss about the topic affective stress. Now my dear students, before discussing about affective stress, let me tell you what do you mean by total stress here. Okay, a total stress can be due to the self weight of soil. Total stress is due to the self weight of soil and also due to the overburden pressure or due to overburden pressure. Okay, let me tell you with a simple thing, with a simple diagram here. So my dear students, total stress is due to the self weight of soil and overburden pressure. Gagan, are you following? Now my dear students, suppose if I consider here the soil particles. Okay. Now, if you consider this as the entire load, this as the load and this is the entire area, load upon the entire area will be the total stress. But in this, there will be some water filled in the voids. Okay. The stress due to water or you can say pore water is nothing but neutral pressure. What sir? We have a pressure called neutral pressure or you can say it is pore water pressure. What is neutral pressure means? It is the pressure exerted by water. It is the pressure exerted by water on a saturated soil mass. Okay. It is the pressure exerted by water. It is the pressure exerted by water is known as neutral pressure. Why it is called neutral pressure? That is the first question you will ask me. Why it is called neutral pressure, sir? Because it does not influence the engineering properties of the soil. Why it is called neutral pressure? Because it does not influence the engineering properties. Okay. It does not influence the engineering properties of soil. That is the reason it is called as neutral pressure or you can say pore water pressure. Now my dear students, how do you represent pore water pressure? Pore water pressure is nothing but gamma W into HW. What is pore water pressure, sir? It is nothing but gamma W into HW. What is gamma W here? Here it is nothing but the unit weight of water. Gamma W, which I have told you already, it is equal to 9.81 kilonewton per meter cube or you can say 1 gram per centimeter cube or you can say 1 ton per meter cube. So my dear students, this is all about the neutral pressure. Any doubts you can ask me, students. Now coming to the effective pressure. Now coming to the effective stress. What is effective stress means? It is the intergranular pressure between the soil particles. What, sir? Now my dear students, if you see, effective stress means it is the intergranular pressure. It is the intergranular pressure. It is the intergranular pressure between the soil particles. It is the intergranular pressure between the soil particles, Now my dear students, you can have a doubt here. Sir, how do you measure the effective stress? See students, if I represent here, effective stress is represented as sigma dash. It cannot be measured directly. Effective stress cannot be measured directly, my dear students. Actually, if you see all the engineering properties of the soil, you can judge or have an idea based on the effective stress. Are you following, my dear students? Gagan, are you following? If you have any queries, you can ask me. Now, see students, effective stress can be written as total stress minus pore water pressure. How do you write effective stress? Effective stress is written as pore water pressure minus, total stress minus pore water pressure. So to find out the effective stress, my dear students, you should be aware of the total pressure or total stress and the pore water pressure. Then you can find the effective stress. I hope you are clear. Now let us understand with the cases. We have a beautiful case one. We'll understand how the stress, see this is all diagram, students. First of all, in case of a surcharge, what is a surcharge means? Suppose if a building is there, on top of a building you find a cell phone tower, because it is a static load which will act throughout the soil, that is nothing. A building on top of a soil can be a surcharge, right? So here if I talk about the diagram, in case of surcharge, suppose if I have considered a soil like this, okay, if I have a surcharge loading Q here, this is surcharge loading Q, how the stress distribution will be? You can say if I consider total stress distribution, total distribution will be Q at top and also total stress will be Q at bottom. You can say stress at the top is Q and stress at bottom is also Q. So from this what you can understand, it is varied in a linear variation, right? It is varied in a rectangular variation. So you from this you can say in case of surcharge, the total stress varies uniformly. Uniformly means it is constant throughout the depth. Varies uniformly means what, my dear students? It is constant throughout the depth. So here let me tell you, when I talk about the total stress distribution, in case of a surcharge or a building on top of a soil, which is a constant weight, the stress due to this building will be uniform, okay? Now my dear students, let us understand, if a soil strata is there here, which is having a depth Z, and unit weight of the soil is gamma. So this is case 2. Now my dear students, if you see how the total stress distribution will be is, if I represent total stress as sigma, here it will be distributed in a hydrostatic way, or you can say linear way, okay? So here what will be the value here is, the value here will be equal to gamma into Z, okay? This is the one. Now do you find any water table here? No. So you can say if I represent a pore water pressure here, you can say here the pore water pressure is 0. So you know the pore water pressure, you know the total stress. So total stress minus pore water pressure can be written as effective stress, and this can also be written as gamma into Z. So this can also be written as gamma into Z. So my dear students, very good Gagan, it will be in a triangular variation, very good, or hydrostatic variation. So from this case what you can write here is, you can write a note here. You can write that if there is no water table, if there is no water table, if there is no water table, total stress will be equal to effective stress. So my dear students, effective stress comes into picture whenever there is water table only. If there is no water table, you can say that the effective stress and total stress are same, okay? Next, case 3. Suppose case 3 is in case of water table, we can write. Case 3 is, you can write in case of water table. What we do in case of water table, let us understand. Gagan, I hope you are following. Suppose C students, if we consider this as the depth as Z and the water table is at top. Okay. Now what is the condition of the soil? They might give you gamma sat. Okay. Now see students, let me tell you how do you calculate total stress here. Here total stress will be calculated as, you can say it is calculated as gamma sat into Z minus, this is total stress, minus pore water pressure, you can say it is written as gamma W into Z, because depth of water table is at a Z. Are you following? Now what will be the effective stress, sir? Effective stress will be equal to gamma dash into Z. Sir, if you see here, I will tell you. If you see the lens here, here I am showing more, here I am showing less here. Usually what happens, no? Gamma sat will be greater than, gamma W will be greater than gamma dash. That is the reason why I am showing this depth, this lens small. Okay, you might have this question in mind. So remember, my dear students, the important note point I would like to tell you here is, in case of water table, what sir? In case of water table, in case of water table, you can write that gamma sat will be replaced by gamma dash in the calculation of effective stress. How I got gamma dash, sir? If you see here, see students, if you are seeing here, how do you calculate sigma dash? It is nothing but total stress minus pore water pressure. You can say gamma sat minus gamma W if I take common Z. What do you mean by gamma sat minus gamma W? It is nothing but gamma dash into Z. So this is nothing but the effective stress. Okay, I hope you are clear with this concept of water table and all. Okay. Now, if I talk about case 4, now see, if I talk about the case 4, suppose if you have two soil strata depths, gamma 1, here depth is Z1, and we have two different soil stratas, gamma 1, and here if you talk about Z2, and if you write gamma 2. Now anyhow you know there is no water table in this question, my dear students. So what you can say, total stress and effective stress both will be same as there is no water table. Yes or no? So in this case, how do you solve the problem? So if you draw the total stress, people will think like this. Here if you see students, this is can be written as gamma 1 into Z1. Here you will write it as gamma Z1 plus gamma 2 Z2. Now my dear students, if you have drawn the diagram in this way, I would like to tell you this is absolutely wrong. This is absolutely wrong. Why? Because see, in this soil strata, the entire soil is not having the same unit weight. At the top depth Z1, up to depth Z1 it is having gamma 1, and up to depth Z2 it is having gamma 2. So there the unit weights are changing. So how do you represent the total stress here is, if you see here you can write due to the slope changing, this is how the diagram look like. So here you can say it is gamma 1 Z1, and here it is gamma 1 Z1 plus gamma 2 Z2. You can write a note that slope changes. Okay. Okay, is this clear, sir? I hope you are clear. Okay. Now see students, let us solve one problem, a beautiful problem, so that you will get an idea. I want everyone to solve this problem, students. Are you following, students? Any doubts you can ask me. So this is the problem which is having. Now what you have to do is you have to calculate the effective stress. Calculate the effective stress at bottom. I'll give you 2 minutes of time, students. Just give a try with this problem. Please give a try with this problem, students. Please let me know what is the final answer. Okay, see students, I have given you enough time. Let us move on to the question. Okay. Now see students, how easily we can solve, let me tell you. Here it is 3 meter. This is 2 meter. And here it is gamma is 18 kilonewton per meter cube. And here we have water table, and this is gamma sat is equal to 20 kilonewton per meter cube. Okay, if you talk about the solution, here it is having 50 kilonewton per meter square. Now my dear students, I have discussed different cases here. Okay, I have discussed different cases. Let me check, Arvind. So what is the value, sir? It is 50. So 50 means 50 will be uniform throughout the case. So it will be 50 here and it will be also 50 here. And now see students how easily I will solve. This is 18, this is 3. So total stress and effective stress will be same when there is no water table. So here it will be equal to, this is 50, this is equal to 18 into 3, that is 54. So this is 50 plus 54, you will have 104 kilonewton per meter square. Now what is asking? The stress at bottom, right? Now what is this, sir? 2 meter, right? So it is 2 meter. If you talk about 144, then it is absolutely wrong because I have told total stress or effective stress. Here I have told effective stress. Arvind, please check it. Here I am asking you the effective stress, not the total stress. If it is total stress, I totally agree, you will get 144. But in case of water table is there, whenever water table is there, I told you, whenever water table is present, to calculate the effective stress, gamma sat will be replaced by gamma dash. Gamma sat will be replaced by what, sir? Very good, Arvind. It will be replaced by gamma dash. So assume assume for easy calculations, gamma W is equal to 10 kilonewton per meter cube. So if I write here, what will be gamma dash, sir? Gamma dash will be equal to gamma set minus gamma W. So that is equal to 20 minus 10, that is equal to 10 kilonewton per meter cube. So here it will be equal to 54, this is, and here it is 10 into 2, which is equal to 20. So if you add all this, you will get a value of 124 kilonewton per meter square. So what will be the final answer? You can say 124 kilonewton per meter square. Arvind and Gagan, is this clear for you, sir? So this is how you will answer a question on effective stress. Okay. I hope you are clear. Now see students, let me tell you, if you consider the soil particles, okay, in the voids, it is filled with water. Now, how does this water exist? Sir, see, water exists in three forms in the voids. Water exists in three forms. Water exists in three forms. One we can say is, can anyone tell me first one how the water exists, sir? The first one we have is the structural water. First one we have is the structural water. Second one we have is the adsorbed water. Second one we have is what, sir? Second one we have is the adsorbed water. And third one is known as the capillarity water. So water exists in how many forms, sir? Water exists in three forms. One is structural water, adsorbed water, and capillarity water. So these are the three forms of water, how the water exists in the voids. Agree, my dear students? So let us go to discussion. What do you mean by structural water? Sir, see, if I talk about structural water here, if I talk about the structural water here, what do you mean by structural water here is, let me tell you, if we consider this as a soil particle, if I consider this as a soil particle, if the water is somewhere like this, so structural water is something like it is an integral part of the soil. Structural water is an integral part of the soil. How I will tell you, suppose if you talk about blood, blood exists in what ways? In blood again we have red blood cells, very good Arvind. Red blood cells we have, white blood cells we have, again we have erythrocytes, leukocytes, same thing. But similarly in water also, as it is an integral part of the soil, this structural water cannot be removed by oven drying. What, sir? As it is an integral part of the water, it cannot be removed by oven drying. Ordinary oven drying, you can say, it cannot be removed by, because if you do oven drying, definitely water should evaporate. But this structural water cannot be removed by ordinary oven drying. Because why it cannot be removed by ordinary oven drying, sir? Because it is an integral part of the soil. Okay, next, similarly, if you talk about the adsorbed water. Similarly, if you talk about the adsorbed water, sir, if you talk about soil structure, I have explained you this. What do you mean by adsorbed water? Sir, see, adsorbed water is something like this. The water which is held in the zone of diffused double layer is known as adsorbed water. Water which is held in the zone of diffused double layer. Water held in the zone of diffused double layer is nothing but adsorbed water. Now immediately you people will ask me, sir, what do you mean by diffused double layer? Sir, actually if you consider this as a clay particle, there is a layer on the clay particle up to limit of attraction. The layer on the clay surface up to limit of attraction, due to electrical forces. What, sir? The layer on the clay surface up to limit of attraction due to electrical forces is known as diffused double layer. Is known as what, my dear students? Diffused double layer. So the whatever which is the held in the zone of diffused double layer, that water we call it as adsorbed water. And adsorbed water causes, why it is dangerous? Because it causes plasticity to clay. What do you mean by plasticity, sir? The ability of the soil to deform without rupture. So this adsorbed water will causes plasticity to clay. So what do you mean by adsorbed water, sir? The water which is held in the zone of diffused double layer is known as adsorbed water, and adsorbed water causes plasticity to the clay. Now let us understand capillarity water. Now let us understand capillarity water. Now let me tell you what do you mean by capillarity water, sir. Sir, before understanding capillarity water, let us understand this term. What do you mean by capillarity? Now see, students, the rise or fall of a liquid, is known as capillarity, right? The rise or fall of a liquid is known as what, my dear students? It is nothing but the capillarity. Now actually if you see, if we consider these are the soil particles, and if you consider these are the soil particles, what I would like to tell you here is, here see, the interconnected voids here will act like a capillarity tube. What, sir? The interconnected voids will act like a capillarity tube through which the water might rise or the water may fall. What, sir? The interconnected voids will act like a capillarity tube through which, here see, if you consider here, if I consider this as a water, sir. Okay. Now let me tell you, students. Now what do you mean by capillarity fringe? Are you following Arvind and Gagan? Gagan and Arvind, are you following? Please comment in the chat box. Now see, let me tell you. The interconnected voids will act like a capillarity tube. The interconnected voids will act like capillarity tube through which water rises or falls. It acts like capillarity tube through which water rises or fall. The interconnected voids will act like capillarity tube through which the water will rise or fall. Now, my dear students, if I talk about this phenomena is known as capillarity fringe. What, sir? This phenomena is known as capillarity fringe. They can ask you, what do you mean by capillarity fringe? Means the interconnected voids will act like a capillarity tube. Sir, this is acting like capillarity tube and the water can rise or fall. Okay. Now see, students, if I talk about this, if I consider this as the voids, okay, and if I consider this as a void, okay, and if I consider this as the water, now see, if we consider this as a walls, okay, the water will be under tension and this water causes compression to soil mass. Are you getting me, sir? If you see here the water, if I consider this as water, it is moving, see here, it is moving in this way, it is trying to escape. So capillary water here will be in what, sir? It will be under tension. But what does this water is doing to the soil? It is creating compression to the soil mass. Yes or no? So please write down here, students. Capillary water, capillary water, capillary water causes capillary water causes compression to soil mass. What, sir? Capillary water causes compression to, you can say capillary water causes compression to soil mass. And remember, my dear students, capillary water will be under capillary water. Capillary water will be under capillary water will be under tension. Okay. So please understand here, students, how this will act. Okay. What do you mean by capillary fringe? The interconnected voids will act like a capillary tube through which water may rise or fall. The interconnected voids, okay. Now, how this water behaves? This water is going to cause compression to the soil mass, but the water will, capillary water will be under tension. Now, see students, you might be knowing, how do you calculate capillary height, sir? How do you calculate the capillary height? How do you calculate the capillary height? How do you calculate capillary height, students? Capillary height HC is calculated as 4 sigma s cos alpha. Capillary height can be calculated as 4 sigma s cos alpha into gamma WD. Okay. Now, my dear students, what do you mean by sigma s here? Sigma s is nothing but the surface tension. What do you mean by surface tension, sir? Force per unit length is nothing but the surface tension. Now, see students, here what do you mean by alpha? Okay. Suppose if you consider here a tube, capillary tube, and if you consider this as a meniscus, and if you consider what is this angle, sir? Alpha is nothing but the contact angle. Alpha is nothing but what, sir? Contact angle. Now, anyhow, D is nothing but the dia of tube. What is D, sir? D is nothing but the dia of the tube. So, here capillary height is given. Now, this formula can be simplified as, capillary height will be in meter. It can be simplified as 0.3. D should be substituted in centimeter. Okay, capillary height is simplified by the formula 0.3 into D centimeters. Angle of the contact angle. Very good, Gagan. Very good. So, this formula is, actual formula is this one. This if you substitute, because you know what is gamma W, what is surface tension, and if you substitute this formula can be simplified into this way. Now, let me tell you one important thing, sir. Actually, if you calculate effective stress, now how do you calculate effective stress in the zone of capillarity? Okay, sir. Suppose if I considered this as capillary height HC. Okay, remember, my dear students, I will tell you very important thing, sir. I will tell you one very important thing here is, effective stress will be calculated as gamma sat into HC. What, sir? Effective stress will be calculated as gamma sat into HC whenever there is a capillary zone. So, here usually what happens, students? See, I would like, whenever there is a capillary zone. Why I am telling this now? Tell me, sir. Due to capillarity, actually, the effective stress might increase, because if you see in the effective stress calculation, whenever there is a water table, you are using gamma dash, but here you are using gamma sat into HC. That is the reason gamma W into HC will be the value increased this value, whatever this value gamma W into Hc will be the increased value of effective stress. This is the increased value of effective stress when there is a capillarity zone. When there is a capillarity, whenever there is a capillarity zone, here, okay, this, what is the increase in the effective stress is gamma W into Hc. And remember, my dear students, this you have to keep in mind. In calculation of effective stress, whenever there is a capillarity, that case you have to take gamma sat into Hc. So let me write the actual thing in a table kind of thing so that you will get a better understanding, students. Okay. Now see, students, let me tell you here. Whenever there is a surcharge here, okay, you can say that total stress or effective stress varies uniformly. What's sir? Total stress or effective stress varies uniformly. Here if you see, I will draw with a simple example how this will be the total stress. Next, in case of no water table, so when there is no water table, you can say that total stress will be equal to effective stress. When there is no kind of water table, what we have to do, sir? There is no difference between total stress and effective stress. Now, in case of water table, for calculating the effective stress, gamma sat will be replaced by gamma dash. Okay. Is it clear? Are you following, Gagan? Arvind and Gagan, are you following, sir? So here is one case, here is the other case. We have, in case of no water, total stress and effective stress will be same. In case of water table, for calculating the effective stress, it is gamma sat is replaced by gamma dash. Now see, students, in case of capillarity, how do you calculate effective stress, sir? In case of capillarity, you can say here, okay, in case of capillarity, effective stress is calculated using by taking gamma sat into account. You can say gamma sat into account. Now, my dear students, let me tell you one important thing, sir. Whenever there is a capillarity zone, effective stress is increased by a value, gamma W into Hc. What, sir? Effective stress is increased by value gamma W into Hc. I hope you are clear. Are you following, students? So these are all about the actual concept for the effective stress calculation or anything. Now let us see some questions, students. I am just giving you very vaguely. Now if I talk about the problem here. Now, if you consider this as 2 meter, we have a surcharge here. Here we have gamma is equal to 18 kilonewton per meter cube. Here we have 3 meter. Gamma D is equal to some 16 kilonewton per meter cube. and here we have a water table which is 1 meter, where gamma sat is equal to 20 kilonewton per meter cube, and here we have surcharge is 100 kilonewton per meter square. Students, I'll give you 2 minutes of time and I want everyone to solve this problem. How do you solve this problem? So let us understand how do we solve this problem. So the first thing, how do we apply the note points here? Here we have surcharge is equal to how much, sir? 100 kilonewton per meter square. So you can say, if I take this as A layer, if I take this as B layer, if I take this as C layer, or if I take this as D layer, let me be any layer. Arvind and Gagan, are you following, sir? Now it is uniform throughout the section. So it is, you can say it is top 100 kilonewton per meter square and bottom also it is 100 kilonewton per meter square. You name any layer. Why it is same, sir? Arvind, are you following? So why it is same here? Because surcharge will be same even it is at top or at bottom. Now let us understand, we have a unit weight of 18 here and it is having 2 meter. Now let me tell you, in this layer there is no water table. So whenever there is no water table, total stress and effective stress will be same. Sir, here they are asking to find out the effective stress, okay? Here please understand, my dear students, we are going by layer by layer. So whenever there is no water table, total stress and effective stress are same. So this value will be equal to how much, sir? So if I consider here, this is equal to 18 into 2, which is equal to 36. So this value is 100 and this is 36. So I can write it as 136 kilonewton per meter square. Now this will be a surcharge here. And here there is a dry weight of how much, sir? It is 16 and this is 3 meter. Here also there is no water table. So here also no water table. Let us see. So here it is 16 into 3, 48 kilonewton per, 48 and 170, it will be 184 kilonewton per meter square. Sir, my dear students, here you have to change the slope. Slope is not same. So whenever it is having different unit weights, I told you clearly the unit weight, like the slope changes. Very good answer, Gagan, very good answer. So if you talk about here, this is gamma dash into Z. Sir, see, in the third layer, we have a water table. So my dear students, here what I would like to tell you here is how to apply the application here. If you know the different cases, how can you find out? Here you can write, whenever there is a water table, you have to write it with gamma dash. So what do you mean by gamma dash here? Gamma dash is nothing but gamma set minus gamma W. So here what is gamma set? 20. Gamma W is 10. So it will be equal to, gamma dash will be equal to 10 kilonewton per meter cube. It will be equal to how much, sir? 10 kilonewton per meter cube. Yes or no? So it is having a depth 1. So here it is 10 into 1. So you can write here, this is 36, this is 48, this is 10. So 146, total value will be 194 kilonewton per meter square. Sir, if it is total stress, what will the total stress means? It will be equal to 204. Sir, because if you just add the pore water pressure, effective stress plus pore water pressure is nothing but total stress. Here you got effective stress as how much, sir? 194. Now if you talk about the pore water pressure, there is water table here. So 10 into 1 if you add, total stress will be equal to 204. Just to tell you how to calculate the total stress and the effective stress. I hope you have enjoyed this session. Now my dear students, let me tell you here what we have discussed in the today's session. So here what we have discussed in today's session is, we have studied about the total stress. Total stress is due to the self weight and overburden. Effective stress is the intergranular pressure between the soil particles. It has a measurable influence on engineering properties. It cannot be directly calculated. Until unless you know the total stress and the pore water pressure, effective stress will be calculated. We have different cases whenever there is a water table, So in case of water table, effective stress will be calculated by replacing gamma sat with gamma dash. In case of total stress and effective stress will be same when there is no water table. In case of surcharge, the effective stress will be uniform throughout the depth of the soil. And in case of capillarity, the effective stress will be calculated by taking gamma sat into account. In this case, the effective stress will be increased by a value gamma W into Hc, where Hc is the capillarity height. We have three forms of water. One is the structural water, which is an integral part of the soil and it cannot be removed by ordinary woven drying. And we have the adsorbed water, the water which is held in the zone of diffused double layer is nothing but the adsorbed water. So what do you mean by diffused double layer? The layer on the clay surface up to limit of attraction due to electrical forces is known as diffused double layer. So here this adsorbed water creates plasticity to clay, my dear students. And when I talk about capillarity, the rise or fall of a liquid is known as capillarity, and the interconnected voids will act like a capillarity tube through which the water might rise or fall. This phenomenon is known as capillarity fringe. And for your information, my dear students, due to capillarity, there are two conditions we'll also observe. We have frost heave and frost boil. These are observed in cold countries like Switzerland, European countries, or you can say in India, Kashmir. Actually, due to the sudden melting of water, the water level suddenly rises. That is nothing but frost heave. So that is nothing but frost boil, because water melting, no, then it will be frost boil. Similarly, as water gets lowered also when the temperature is too cold, then the water gets form into ice. So these are the another two conditions, frost heave and frost boil, which are occurring due to the capillarity action. Now what we do at IMS GATE Academy, myself Sandeep Adari, my dear students, we at IMS GATE Academy provides 800 plus hours of GATE coaching. We provide online sessions, offline sessions, and also the self-recorded sessions. We at IMS GATE Academy provides you subject-wise material, exercise book. In exercise book, we have level 1, level 2, level 3 questions. It includes both NIT, MSQs and multiple choice question. Now, my dear students, the premium product what we have is the GATE question booklet, which we call it, which covers 35 years of previous year GATE questions with alternative solutions, with key pointers, and wherever you find difficult levels questions, you will have the recorded solutions for that. And remember, my dear students, we are providing 130 plus tests. Why? Because you want to test every juncture of your time. Like you want to test yourself with chapter test, subject test, multiple subject test, advanced level test, or you can say all India mock test, which will be a replica of the GATE environment. In addition to this, we are providing 12 one-to-one mentorship. These are the key success for the student to capture the success in the GATE exam. Why? Because will be discussing the entire roadmap for the GATE 2025, which he has taken the admission. In addition to this, we will understand what is his weakness, what is... Good evening. And good evening. Now see students, let me tell you what I would... Good evening, Darshini. See students, what I would like to tell you here is see students, apart from this one-to-one mentorship, I want to let you know the other important things, like we are providing the doubt solving portal where the doubts can be resolved within 24 hours of time. So these are all the key features of the IMS GATE Academy. So my dear students, if you like our sessions, the motto of the foundation series is once you start preparing for the GATE exam, your basics should be stay tuned. So in this basics, how you can tune yourself is by understanding the simple concepts. And let me tell you, we at IMS GATE Academy offers offline GATE coaching at Jayanagar, and you have the education advisor, Mr. Rahman. He'll be guiding you what are the key features what we provide at IMS GATE Academy, what we do, what are the batches we have offline. Like in the offline also we have weekend batches, weekday batch and all. So you can come in touch with Rahman. These are the contact numbers, students. Or if you don't have the contacts, you can just join the Telegram group and get the contact of Rahman, and he will definitely help you how is the journey at IMS GATE Academy. I hope this video, in this session, I have covered the effective stress, the basic concepts, how to solve the problems in different cases. Thank you and all the best for GATE 25.